Hi guys, so let's look at oxides of metals and non-metals in this video. So metal oxides are basic oxides, which means that when they react with water, they form a solution that has very high pH, so pH which is above 7. So these metal oxides, they react with water to form the metal hydroxide. So sodium oxide will form sodium hydroxide. So this is what you have. So that's the formula of the metal oxide. So you have sodium oxide reacting with water to form sodium hydroxide. So this is going to be the same for all the metal oxides, and because this is alkaline, so we say that these are basic oxides. So you are going to complete the equations for each of them and make sure that your equations are balanced. Non-metal oxides, they are acidic oxides and they react with water to form acidic solutions. So I'll do one example for you. So these are two examples done. So sulfur trioxide, SO3, sulfur dioxide, SO2, they react with water to form the corresponding acid. So SO3 will form sulfuric acid, SO2 will form sulfurous acid. Be careful. Carbon dioxide will form carbonic acid. Here you'll have a mixture of nitric acid and nitrous acid. You don't need to know the equation for this one because you have a mixture here. And phosphorus 5 oxide, this is going to form phosphorus acid. Phosphoric acid. Right. Make sure that the equation is balanced over here. These are a few of oxoanions that you will come across. Oxoanions are anions that contain oxygen in them. So CO3 2-, you have a charge that is also given for you not to confuse. So CO3 2- is carbonate. Then you have ethane dioate or oxalate. Nitrate. So there is a rule for the naming. If there is only one oxoanion form, the ending is ate. So just like carbon with oxygen forms only one oxoanion, so it's called carbonate. Here you have oxalate or ethane dioate. There's just one oxoanion. If there is two, the one with the smaller number of oxygen ends with ite, and the one with the greater number of oxygen ends with ate. Just like here, smaller number of oxygen ite, larger number of oxygen ate. Nitrite, nitrate. Sulfite, sulfate. Phosphite, phosphate. So ite and ate. And then if you have 4 oxoanions, just like for chlorine, bromine, iodine, you will have 4 oxoanions. Then you have another rule. So then when you have 4 of them, the one with the smallest number of oxygen, so here there's just one, it will end with ite, and you'll have the prefix hypo. So hypochlorite. Then the next one will just end with ite, and then the one with the highest number of oxygen will end with 8 with the prefix per, and the one before is just going to end with 8. So if you'd like to, just for you to remember the naming, let's look at the middle two. So the middle one that has smaller number of oxygen ends with ite, larger number of oxygen ends with 8. If it has one oxygen less, then hypoite, then one oxygen more, per 8. These are the prefix and the suffix. So it's just for you to know the naming, and then OH- hydroxide. Okay, so you can write down the main points for the rules for naming oxoanions. Silicon dioxide is another interesting oxide, but it does not dissolve in water. If you still remember, silicon dioxide has a giant molecular structure. It's a macromolecule, therefore it does not dissolve in water, but it is classified as an acidic oxide because it will react with a base. So silicon dioxide will react with NaOH to form sodium silicate and water. You'll have to write a reaction for this. You have the reactants, you have the product. I think you can write a chemical reaction. Now, silicon dioxide is sand. So, of course, sand does not dissolve in water, but it will react with an alkali. Aluminium oxide is classified as an amphoteric oxide. This means that it reacts both with acid and a base. So we can have one reaction for aluminium reacting with an acid. So you have the equations. So this is sodium hydroxide. Well, it's an aluminate salt. It's sodium hydroxyaluminate. It's an aluminate salt. You actually don't really need to know the equations for this one. You just need to know that it reacts both with an acid or a base. Okay, here you go. This is a better equation where you have the sodium hydroxyaluminate salt, but like I said, you don't need to know the equations by heart. You just need to know that it is amphoteric. Aluminium oxide is amphoteric. It will react both with acid and base. So across a period, you will see that the nature of oxides change from basic to amphoteric to acidic. So sodium oxide, magnesium oxide, they are basic. They will react with acids. Aluminium oxide is amphoteric. It will react with both acids and base. And the non-metal oxides here, they are all acidic and they will react with bases. You also need to know the reaction of the alkali metals with water. So group 1 metals react with water, and this is a very vigorous reaction, and you can see the descriptions. Read the descriptions for each group 1 metal. So as we go down the group, the reactivity is increasing. So it becomes more reactive because the size of the atom is increasing. So it becomes easier for the atom to lose the valence electron, which means that it's going to make it become more reactive. So it's going to react with water to form the hydroxide and hydrogen gas. Group 17 elements, they are all diatomic molecules, and the state of matter at room temperature changes from gas to liquid to solid. So bromine is the liquid one, and then you have the two solid at the end of the group. Halogens are generally highly reactive as they readily combine to gain an electron, but as you go down the group, reactivity decreases because radius increases and it becomes less easy for the halogen to gain an electron. So here, down the group, the charge density is decreasing, so effective nuclear charge is kind of decreasing because we have that shielding effect. So it becomes it becomes harder for it to gain an electron. Now, reaction of halogens with alkali metals. Halogens will react with alkali metals to form the ionic metal halide. So if you have sodium with chlorine gas, you will have sodium chloride, which is formed. So you have the metal halide. Reaction of halogens with halides. Now, halogens can react with halides in a displacement reaction. So you will have a more reactive halogen that can replace the less reactive halide ion. So let's see. So if you have chlorine reacting with potassium bromide, so chlorine is more reactive than bromine because chlorine is higher in the group. Chlorine will displace bromine from potassium bromide. So this is what you have. So chlorine is more reactive than the Br chlorine is more reactive than bromine, so it will be able to displace Br minus from an aqueous solution, so that you have potassium chloride which is formed and bromine which is displaced. Now you will have a color change because this is a pale yellow color or pale yellowish green color, and this one is reddish brown, so you will have a color change depending on the halogens involved. So this is the color change that you will see. So you'll see reddish brown color, and you have a summary of all the color changes and all the reactions that will occur between the halides. So this is what you have, and be careful, this is an aqueous solution for it to be able to displace it. So you need to have one halide. You need to have one halogen that will react with a halide. So the halogen has to be more reactive than the halide. So make sure you note these down. The color changes are very important. And oxidizing ability down the group. Halogens have tendency of accepting electrons, and when you're accepting electrons means that you are undergoing reduction. So means that halogens are easily reduced, and if something gets reduced, it is actually acting as an oxidizing agent. Remember, oxidizing agents, they cause oxidation, but they are themselves reduced, which means that halogens are very good oxidizing agents. And as you go down the group, atomic radius is going to increase, and it's going to be less easy to accept electrons, which means that as you go down the group, ability to oxidize is going to decrease. So make sure you note that down in your copybook, and you're going to do the questions for the end of unit. So this is it with unit 3.2. Thank you.